Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Khairi Beria. In this video, I would like to share about my project. So, firstly, we go through with the introduction of this project. Firstly, we need to study the making of sustainable feature brick for potential application in civil engineering field. Based on the study conducted, the amount of demolition waste is increasing daily, and the lack of non-renewable resources for manufacturing material in building is occur every day. Initiative in addressing the problem of manufacturing building material by using waste material are generated. Objective of this project is to study about how to manufacture the brick by using clay brick, waste and soft sludge. Okay, next we need to identify the method used. The material used for the fabrication of brick were ordinary Portland cement, laterite, sand, clay brick waste and soft sludge. Okay, next, before start the activity, all raw material were crushed and sieved to the particle size finer than 4 mm. And then, the soil cement brick sample is produced by manual brick making machine. The dimension of the soil cement brick sample is 100 mm times 125 mm times 250 mm. Okay, next, the composition of brick is by using ratio 1:c, which is the OPC to aggregates by weight. The test that involved in this study is normal porter test and then the compressive strength test. So the normal porter test is needed to determine the amount of required water for the pressing process. Then the compressive strength test is needs to determine the characteristic of brick. So next we go through with the result of this project. So the sustainable content is have two, which is clay waste brick and clay brick and soft sludge. Okay, for clay waste brick, the brick with 10% replacement of laterite by clay waste brick have the highest compressive strength, which 10% replacement, and then above 10% there were a slight decrease in compressive strength. Then, in terms of the bulk density, the bulk density decreases with the addition of clay waste brick in the brick. Then, the water absorption of the brick sample containing clay waste brick is higher. So next, the sustainable content for clay waste brick and soft sludge. The bricks prepared from C10 over S10 formula have the higher compressive strength. C10 is defined as 10% of clay and S10 is defined 10 of soft sludge replacement. And then the bulk density is decreases and the water absorption also increase. Okay, next we need to discuss about the result obtained. The study focus on the uses of the clay brick waste and soft sludge in the creation of environmentally friendly building materials. There are some aspects that's needed to consider to use these materials. Firstly, the compressive strength of material need to determine. Okay, we can see that the compressive strength when replace 10% of clay brick waste is higher. It's also same with C10 over S10 formula, but the 10% replacement of clay brick waste is greater than when we using the formula C10 over S10. Then, secondly, the bulk density is needed to determine. The bulk density will replace the clay brick waste is decreases. It also occur when we added the soft sludge. There are also effects with water absorption. There are higher water absorption needed by using both material to produce the brick. Next, we need to discuss the question. So firstly, how well the study? Research is efficiently because the material used related and easily to find. Then, it also will reduce the pollution and at the same time will reduce the cost of construction. So this material used is a waste material. So we can get easily the material from the construction waste. Then, how accurate were the results? Results of this research are very convincing because it's conducted by reference the knowledgeable people. The experiment conducted also related with our study and easily to understand. So we have also learned about how to find the compressive strength and the bulk density. So this is easily to we understand. Okay, next, what aspect of the research work were unclear? Okay, based on observation, this research not repeats the experiment to get every result. So it is difficult to detect the possible error occur, and the research also not determine what is the possible error in this activity. So next, how do the study going to contribute to development of future sustainable product? Okay, the study able to produce material used in construction material in future as sustainable material, and it's also will reduce manufacture of building material that use non-renewable material resources. Okay, as a conclusion of this project, manufacturing of brick by using a clay brick waste is suitable as sustainable material, but the composition of clay brick waste material is needs to refer with a formula to make a brick. The suitable replacement of clay brick waste is 10%. It is because it will be suitable in terms of compressive strength. Then the benefit that we'll get by using the clay brick waste material is we can reduce the pollution and reduce the cost of construction, and we also can reduce the uses of non-renewable resources as construction material. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Jasmina binti Rasmadi. I will present about fabrication and testing plastic sand bricks. Fabricating and testing of plastic sand bricks was conducted by Department of Mechanical Engineering by Bajaj Institute Technology and Management in India. Why plastic waste was chosen for bricks purpose? Plastic waste is non-degradable substance, which is plastic is not easily to be destroyed and degradable for centuries. So, engineers and researchers use plastic waste for bricks material for recycle purpose to lead us to our sustainable goals. Other than that, plastic waste is strong and durability material, which can give a large compressive strength for the bridge. Other than that, plastic waste is way more cheaper than ordinary bricks, so it can cut the cost and cost efficiency. Plastic waste, along being non-degradable and hazardous material, widely used by humans. Plastic waste causes land and water pollution. The most used type of plastic waste is polyethylene (PE). It is usually used as plastic bag at shopping mall or a supermarket and plastic bottles. Hence, we can recycle and reuse plastic waste and turn it to plastic bricks. Plastic is lightweight, waterproof, and easy to mold. The researcher found that plastic waste can be used for bricks. The use of plastic as a material for bricks will eventually promote sustainability development. Moreover, in research study, plastic waste has more compressive strength than ordinary bricks. Procedure. Firstly, collect the bottles, clean and dry the PET bottles. Second, cut the PET bottles into small pieces. Use shredder for shredding the bottle into small pieces. Third, the small pieces of PET bottles was put into drum for burning process. After the PET bottle melt, then mix the melt of PET bottle with sand. After the mixing process, the mixture of PET bottles and sands were put into a mold for molding process. After that, leave it for 24 hours, then remove the bricks from the mold. This is the list of the tests that researchers test on the bricks. First is compressive strength test, which is to evaluate the strength of bricks. Then water absorption test, to determine the water absorption percentage of plastic sand bricks. Third, efflorescence test, which is to determine alkali presence in a bricks. Fourth, fire resistance test. This is the purpose of this test is to evaluate the resistance of bricks to fires. And lastly is test, which is to determine the relative rise in temperature of plastic sand bricks and clay bricks. Next, it is the result of compressive strength test. The three tables result and graph shows that the maximum loads and compressive strength test each of the bricks can hold. For table 2.1, compressive strength for 1:2 plastic to sand ratio, the plastic sand brick can hold the biggest maximum loads and compressive strength than the other two brick specimen. For table 2.3, compressive strength for 1:4 plastic to sand ratio, the plastic sand bricks can hold the lowest maximum loads and compressive strength than the other two tests. It is because the 1:4 plastic to sand ratio has more sand in the plastic sand bricks. Next is the result of water absorption test for plastic sand bricks. The 1:4 plastic sand bricks has the largest water absorption percentage than the other two tests. And 1:2 plastic sand bricks has the lowest water absorption percentage. Meanwhile, the 1:3 plastic sand bricks has the average and more to same with the 1:4 sand bricks percentage result. This is because the sand can absorb more water. This is the table stated in the studies for effervescent test for alkali percent reference. We can determine the category of the bricks by see the percentage of alkali presence on the surface of a bricks. So we can determine whether the bricks is nil, slick, moderate, heavy or serious. Next, this is the result for relative rise temperature between plastic sand bricks and clay bricks. The specimen used for this testing is 1:2 plastic sand bricks, 1:3 plastic sand bricks, and clay bricks. The initial temperature for the three specimens is quite similar, which is 1:2 plastic sand bricks has 36 degrees Celsius, 1:3 plastic sand bricks has 35.8 degrees Celsius, and clay bricks is 36.2 degrees Celsius. After 30 minutes, we can see that the clay bricks temperature increase higher than the other two specimen. And then after 45 minutes, we can see that the clay bricks temperature increase rapidly, which is the temperature of clay bricks after 45 minutes is 54.3 degrees Celsius, and for the other two specimens, 1:2 plastic sand bricks is 45.2 and 1:3 plastic sand bricks is 46.4 degrees Celsius. In these studies, it proved that the plastic sand brick is no less great than the ordinary bricks. Plastic sand bricks give some advantages for building construction. This type of brick is lightweight compared to the ordinary clay bricks. Furthermore, the main purpose of these studies using plastic bottles as a brick materials is to recycle the plastic waste in order to achieve our sustainability goals. According to the result obtained, plastic sand bricks have low percentage in water absorption. This means that the plastic sand bricks have less porosity. The test was conducted with 3 different ratios of sand, which are 1:2, 1/3, and 1/4. The ratio 1/4 has more percentage of water absorption than the 1:2, is because the sand can absorb more water. Other than that, during the test to determine the relative rise in temperature between plastic bricks and clay bricks, both bricks was tested with burning coal. It's turned out that the temperature of clay bricks increased rapidly. Although the conductivity of plastic sand bricks is lower than the clay bricks, continuously exposure to the high temperature above 350 degrees Celsius lead the bricks to melt. So, plastic bricks is not suitable to use in a place where the fire risk present. Lastly, using plastic sand brick for construction would give cost efficiency because it is more cheaper than the ordinary bricks. The researcher has found a way to recycle the plastic waste since it's non-degradable materials. These studies would help us to prevent environmental pollution such as water pollution. In these studies, the researcher did not state or do any comparison between the ordinary bricks and plastic sand bricks for every testing. The only comparison stated in the studies is the relative rise in temperature for both bricks. The limitation in these studies is the result for the efflorescence test, where the researcher did not put the result and percentage of the alkali present in plastic bricks. The researcher only put the reference of alkali percentage in bricks. The result provided stated by the researcher is accurate and very convincing. The researcher provide the analysis data such as result in table and even graph of the plastic sand brick testing with different ratio of sand. From the data given, we can compare the result in different ratio in plastic sand bricks. Other than that, the tests have proved the plastic waste can be used for bricks and has its own strength in construction materials. The unclear aspect from this research is the efflorescence test, where there are no results showing the percentage of alkali in plastic sand bricks. The researcher also need to compare the ordinary brick and plastic sand brick for every test for clear understanding. Lastly, this can be used. The plastic waste can be used widely as a sustainable material to produce the bricks. With some improvement, plastic waste is durability, light, cheap, and have more strength and suitable to use in construction. The emission also need a further study and improvement.
Assalamualaikum warahmatullahi wabarakatuh. My name is Syahrini Kamarudin. Today I will be presenting on top performance of non-green brick containing rice husk as a sustainable building material. Let's get started. The study is made by S.P. Mosavi from Civil Engineering Department, College Engineering of Tenaga Nasional, Ikran Unit Road, Kajang Selangor, Malaysia. Research question: it is possible to produce a sustainable brick by replacing with rice husk. As we all know that rice husk is a hard protecting covering of the grain rice. It is also provide a dense source of carbon when composted and is beneficial for soil physical characteristics. What is performance of non-firegreen brick containing rice husk as a sustainable building material? Rice husk can be a great alternative material. Rice husk is commonly available as lignocellulose material. Around 78% of weight of berry grain is received as rice during the milling process, and 22% is received as the husk. The soil can be improved in variety of ways, including soil modification and also soil stabilization. Soil modification is the addition of cement, lime, and aggregate which change the indirect properties of the soil, while the soil stabilization is the treatment of the soil to enable its strength and durability. The manufacturing of the brick requires suitable clay. As a part of the solutions, non-fire brick were made from rice husk as an additive. Production contributes to the achievement of green road stability targets. These solutions aim to determine the compressive and fractional strength of the non-fire brick containing rice husks. The material used in the study is the soil sample from Infrastructure University Kuala Lumpur (IUKL) and the rice residue obtained from the rice mill at Sangha Bypass Road, Sangha Garden, Iran. The process of preparation of the specimen. This is the process of preparation of non-grain brick. The rice husk was made with the dry soil and water content, which was added to the soil containing rice mixture. Then the process of mixing the mixture until it homogenized in order to achieve uniform soil mixture. The soil mixture was transferred to the mold with dimension of 215 times 102 and 65 meter. The mixing and the casting process were completed less than 1 hour. Then the specimen was remolding under the sun from 7, 14, 21 and 28 days under the sun in average temperature of 33 Celsius. This is the preparation of non-firegreen brick. For testing program, there is three tests stated in the study, such as compression strength, fractional strength, and water absorption test. Compression strength under fire brick ring, it is to evaluate the compression strength of the brick or to determine the behavior of material under alert. Fractional strength under non-fire green brick, it is to measure the behavior of the material subjected to the simple load on the brick. Or it is also the ability of the brick to withstand the failure in bending. Water absorption test on the non-fire green brick, it is to obtain the percentage of water absorption of the brick. It also indicates the durability properties of the brick. This is the table tabulated from the studies. Figure 7 shows the effect of the rice husk addition on the algebraic limit of the soil sample. Table 2 shows the compressive strength of non-fire brick after 24 hours without rice husk. The figure 8 shows the effect of aging on the compressive strength of the test specimen. Figure 9 shows the water absorption of the non-fire brick. Then, in the table 3 shows the absorption of the non-fire brick with the rice husk. And in the table 4 shows the fractional strength of the non-fire brick after 24 hours without rice husk. In figure 10 shows the effect of drying on the fractional strength of non-fire brick. Next, the further explanation and discussion on the result provided. The effect of the rice husk addition on the attribute limit of the soil sample. The state limit of the soil specimen increased with increasing rice husk content up to 12%. Liquid limit follow the discernible trend due to the water absorptivity behavior of the rice husk when added to the sample. Discernible trend is the tendency to approach a constant liquid limit. Decrease in the plasticity effects implies sign of improvement of the intact properties of the soil sample during rice husk addition. The result of the compression test on the non-fire brick with the rice husk. The purpose of compression strength test is to determine the best possible strength brick can withstand. The average value of the compression strength of non-fire brick specimen is 2.9 megapascal, which is relatively low. It is necessary to notice that the specimen is tested after 24 hours sun drying, and that is why the compression strength is relatively low. The relationship of the compressive strength versus aging of the unreinforced and reinforced brick specimen with rice husk. From figure 8 shows the significant improvement. The figure 8 shows the significant improvement in 28 days compression strength, which reinforced with 12% rice husk. The higher compressive strength with 12% rice husk is 10.4 megapascal. It indicates progressive improvement in compressive strength. The rice husk fiber creates cementation link among the soil particle, which increases its compressive strength and improves soil matrix. The result of water absorption test on non-fire brick with and without rice husk. From the table 3, the average water absorption of non-fire brick without rice husk is 10.89%. In the figure 9, the water absorption recorded were the lowest absorption, which are corresponding to the non-fire brick with 6% of rice husk. The fractural strength of non-fire brick after 24 hours without rust has. The average value of the fractural strength of the specimen is 0.37 megapascal. It shows the low fractural strength due to the early age of the brick, which required more sun drying. The relationship between fractural strength and drying age of the non-fire brick. The increase of the harsh addition decreases the fractural strength. The addition of 50% rust has, which result in decreasing the fractural strength. It is due to the addition of 3 to 12% rust has to the clay, which strengthen the clay to withstand the fractural load. The high content of the rust has fiber weaken the ability to the clay to withstand the fractural strength. The rust has fiber create a weak plane in the soil sample, which fasten the failure under the fractural load. The optimum content of the rust has is up to 12%. However, the study addressed the research question whether any limitation. The researcher has been completed the studies and developed the best answer in answering the research question. There are some limitations in knowing the recent influence in increasing the fractural strength when the addition of rust has more than 12%. The study also did not do any comparison between the ordinary brick and the non-fire grain brick in order to ensure that the sustainable brick is suitable for. How accurate were the results, and any of the results are convincing? From the studies, the result provided by the researcher is accurate, and where they are provided with the analysis and testing specimen in the table and graph. The result is convincing because the researcher provided the analysis of the data and with and without size, but it can be used to compare the strength of the brick. From the data given, it is proving that the addition of the rust has improved the significant corrosive and fractural strength of non-fire grain brick. What aspect of the research work were unclear? How do the studies going to contribute the development of future sustainable product? In the study, the unclear aspect is the properties of additive conductant as a sustainable material. The physiochemical testing is conducted. It shows the moisture content, average particle size, bud density, ash content, silica content, and the porosity. It also should state the comparison between the ordinary brick and non-fire grain brick with rust has. The consistency of the ratio should be given in order to produce a good quality of the brick. Since the mining process here receive about 22% as a harsh, it can be used as a sustainable material in manufacturing non-fire grain brick as it is more likely durable and has sufficient strength for use in construction.